There are two ways to install Python. First, and the basic way is just to download Python uh, uh, exe file and just install it, and you will be able to use Python. Now, this Python which you will download from here, that is only good for some basic things. Okay, if you want to go into data science, if you want to work on data science and machine learning and these advanced concepts, you will need something more powerful than this standalone Python. Okay, for that, what we do is we install one software called as Anaconda. Python. Okay, search for Anaconda Python download, and the first link which comes up, open it, and you'll be seeing this download button. Click on it. It will download this 600 MB file. You install it. You just have to click next. That's it. Okay. Why Anaconda? Why not just Python? Okay. The reason is Anaconda comes with a lot of pre-installed, pre-configured uh, Python modules. Anaconda uses Python in the background, but it comes with a lot of pre-installed modules such as Numpy, Matplotlib, Pandas, scikit-learn, which we'll use for machine learning. Okay, it also comes with OpenCV if you want to do work on image processing or video processing. Okay, so all those things comes with Anaconda, so that's why we use Anaconda. Okay, now there comes the installation part. Now we need something to write our code on, right? An IDE kind of thing. You can use Python shell, very basic, but we won't use it. We'll go for some professional approach, that is Jupyter Notebook. Okay, well, what you'll have to do is, if you install Anaconda, you will already have Jupyter installed. But if you install it using standalone Python, you have to write pip install Jupyter. Okay, so it will install the Jupyter Notebook. Once it is installed, what we'll do is, I already have a folder which I have created. I will go to that folder. Just bear with me for once. Yeah, so this is the folder I had created. Okay, this. Okay, what I'll do is I'll create a folder here. Okay, I'll go to this folder. I'll right click. I'll click on open in terminal. It will open something like this. So what I did was, you can already do this using, you copy this path, the path to your folder, open cmd, command prompt, write cd and paste that path. Okay, we'll have to go to that directory first. So right now I'm in C drive, but our folder is in G drive. So you would have to write G colon. Now I can write cd, that path, enter. Now you'll have to write here Jupyter space notebook to start your Jupyter notebook. Okay, let's give it a couple of minutes to start. Meanwhile, I'll close the other terminals. Okay, it started and it opened one tab in my browser. So this is what something Jupyter looks like. Click on new, go to new, click on Python 3. It will open one file for you. Okay, it will look something like this. Okay, right now it says it is untitled file. I'll click on this untitled to change the file name. I will write Python basics. Okay, I'll click on rename. So what happened? We created a file with name Python basics. Okay, to run a code, let's see. First of all, we'll discuss something very simple. We'll discuss about numbers, what numbers are in Python. I'll write 1 plus 1. Okay, it should give me 2. I'll click on run. It gave me 2. I'll write 1 minus 1. We should get 0. So you don't have to use mouse and click on run every time. What you can do is just select this cell and press shift and enter. Okay, what it will do, it will execute the this particular line, and it will create a new block for you to write your next line of code. Okay. Yeah. So what we saw addition and subtraction. Let's see multiplication, easy. Let's say division, very easy. Now there's something called as double star operators. Okay, so it is same as, okay, yeah, if I run this, I got 16. Okay, I'll write 2 into 3, I got 8. So what this is, this is same as 2 to the power 3. Okay, so double into is called as the power operator. Okay, if I write 3 to the power 3, what is 3 cube? That is 27. We got 27. Very easy. Then we have something called as modulus operator. Okay, I write 3 mod 2, it gave us 1. What this is? Modulus gives you the remainder when 3 is divided by 2. Okay, if I write 2 mod 2, if you divide 2 by 2, you won't get any remainder. That's why you will get 0 as output. Okay, next thing is, we did this. Okay, we saw this also, we can do this also. Okay, what else we can do is we can combine these two operators like this. Okay, what we did, 2 plus 3 into 5 plus 6, and based on the precedence operator, so this is how you have written this in brackets, so this will be executed first. So it will be executed as, you will get 5, then into, then you will be executing this, you'll get 11, then you'll get 55. Hope this is clear. Okay, now you can create variables also, very easy. You can write x equals to 2, and if we write x, it will give you 2 because you have put value 2 into your x variable. You can write y equals to 3, you can write x into y equals to 6. Very easy. Now let's look at some strings. Okay, I'll write s equals to string in single quotes. Okay, I can write string in double quotes as well. Okay, but at the end it will be printed as one single quote. Okay, so in Python there's no such thing. In Python, for strings, double quotes will also work, single quotes will also work, but you cannot do this. Okay, you cannot do this because you're starting with single quote, you're ending with double quotes. Okay, so this would be give you error. So you can either do this or you can do this. All right, sorry, this. Next is how to print values. You know, just write print and put your variable name. I wrote R, so it printed the value of R. Okay, I'll write print. So we had declared x and y earlier. I'll write x into y. We got 8 because x was 2, y was 3, and we got 2 to the power 3, that is 8. Okay, now there's something called as string formatting. I have a number of 12 and name as, let's say, John. Okay, I want to print these two variables in a string. Okay, what I can do is I'll write name is plus name, and number is plus num. Okay, so this is called as string concatenation. So what we are doing is we are concatenating multiple strings using plus operator. Okay, this will give you error. Why? Because this is a string, this is a string, this is a string, but this is a number. Okay, and it says you can only concatenate string, not integer, because this num was integer. Okay, so how to solve this? We'll write str of num. Okay, now this will print. Now let's look at what our string formatting is. Okay, I'll write name is x and number is in curly braces y. Okay, now I'll write dot format. Okay, x equals to name, y equals to num. See what it did at place of x. So we have name is curly braces x. So what this means is this will treat this as a curly braces x as a number. Okay, and where we'll get the value of x, we'll get from here dot format x equals to name, and we have name variable called as John, and curly braces y variable that you'll get from num. We have num equals to 12, so we printed this. Next is lists in Python. Okay, like name suggests, list is a collection of values. Okay, and how do we write list? In square brackets. Okay, I'll write 1 comma 2 comma 3. So what it will do is it will create, and I'll write L equals to. So what it will do is it will create a variable called L, and it will have this collection of values. Okay, I'll print L. We got 1, 2 and 3. Why? Because this L has 3 values. Okay, this is something similar as arrays in C or Java, which you might have studied. Okay, but the difference, but it is not array. Okay, there's no such thing as array in Python. The reason, okay, why it is not array? The array by definition says it should be a collection of homogeneous values. Okay, but in Python strings we can have heterogeneous values. So these first 3 are number and the last is string. I'll just write so okay, it executed, meaning there's no error. So what it means is a list can have heterogeneous values. Values. All right. Now let's look at indexing in strings. Okay. How do we use indexing? Okay. Let's say this is our L. L has 4 elements. Okay. We want the first element from the L. What will write? L in square brackets 0. We got the first element. Okay. If we want second element, we'll write L of 1, 2. Okay. Why 0? Why 1? So think of it as a 4 numbers. Sorry. Okay. Think of it as 4 spaces in your memory. Okay. At space 0, you have number 1. At space 1, you have number 2. At space 2, you have number 3. At space 3, you have your word hello. Okay, what do I mean by spaces? Okay, these are nothing but called as indexes. At index 0, you have number 1. At index 1, you have number 2. At index 2, you have number 3. At index 3, you have string hello. All right, I hope this is clear. Now what we want is, now I mean there's something called as list splitting. Okay, how? Okay, I'll write L 1 colon. Okay, I'll just run it, see what happened. Our L was 1 2 3 hello. I wrote L1 colon. It means is return all the elements from the list starting from index 1 to end. Okay, this means return everything from index 1 up to end. Okay, now let's write L2 colon. Okay, we got 3 and hello. So what it did, returned everything from index 2 till end. Okay, now let's write L colon 3. Okay, so what this means is return all the elements from the list starting from index 0 up to index 3 but not index 3, or but not including index 3. Okay, so we had in our array 1 2 3 and hello, 0 1 2 and 3. We wrote colon 3, meaning we want everything till index 3. Okay, what is everything till index 3? This is 1 2 3. At index 3 we have hello, but what this means, what we have written is it will not return this index 3. So what we got, 1 2 and 3. Okay, now there's one more thing, 1 colon 3. Okay, starting from 1 ending till index 3 but not including index 3. Okay, I hope this list splitting is clear. So here we had one dimensional index list, meaning we have elements in one dimension. Okay, let's see what is 2D list. L2D. Okay. What this 2D list means is we have lists and inside a list. Okay, I'll write L2D. Okay, so we have one list as a part of this outer list and another list as the second element of this outer list. Okay, how to use indexing in that? If you use L2D0, it will give you the first element, which is again a list. Okay, we got 1 2 3. Now if you want indexing again in that, so you can write L2D0 and 1. So what it means is L2D0 will give you this element, which is again a list. Now you can apply indexing again here. Now you got index 1, that is the 2. Okay, so you got 2. Our next topic is sets. Okay, what are sets? Okay, let's see. I wrote S1 comma 2 comma 3. Okay, I printed S, we got 1 2 3. Now I write S equals to 1 comma 2 comma 3 comma 4 comma 3 comma 2. Now if I print S, we got 1 2 3 4 5 6. What sets are contains only unique values. Okay, let's say if you have a question to solve, you have to write a program to find unique elements from the list. Okay, let's say we have a list as, I'll just copy these values. Okay, so you have unique duplicate elements in your list. To get unique elements, what you can do is write set bracket, inside bracket pass your list, got all the unique elements. If you want to convert it again into a list, you can encompass it, right? List. Okay, so I'll write it in different. All right, hope this is clear. Next we have operators Okay, uh, 1 is greater than 2. Is 1 greater than 2? No, we'll get false. Okay, is 2 less than 1? No, we'll get false. Is 2 greater than 1? We'll get true. Okay, now we got less than, we got equals, greater than, and we can see if 1 is less than equals to 1, this is true, but is 1 less than 1, that is false. Okay, this equality, this less than equals to also checks the equality of them. Okay, same way, 2 is greater than 2, false. Is 2 greater than equals to 2, true. Okay, now is 2 double equals to 2, true. Okay, now if you have studied JavaScript, then in JavaScript, if you do this, you would get true, but here in Python you will get false. Next we have is logical operators. What logical operators are? Logical operators are and, or, sorry, and, or, and, not. Okay, let's see some examples. Is 1 greater than 2? Okay, that is false. And 2 less than 3? Okay, that is true, but we'll get false. Why? Think of it like this: if first operand is false, okay, then return false. Okay, let's see the other one. Okay. If first operand is true, then evaluate the second operand. Okay, and what was our second operand? 2 less than 3, that is true, so that's why we got true. Okay, or you can think of it like, if and will only give you true if both of them are true. You might have heard this in colleges, that AND operator will only give you true if both of the operands are true. Okay, the other one is OR. Okay, it will give you true if any of the operand is true. Okay, and this true if all the operands are true. Hope this is fine. Okay, and there's not. You can write not and write 1 is less than 2. So 1 is less than 2 is false, sorry, true. It will give you false. Why? We are doing not just reverses the polarity. Say, if it is true, it will return you false. If it is false, it will return you true. All right. Next is let's look at some loops. Okay, before loop, there's one function I would like to mention, that is called as range function. Okay. I'll write range 5. Okay. We got range 0, 5. What this is, we'll see. Okay. If I write list of range 0, 5. Okay. We got a list from 0 to 5. Okay, if I write either 0, 10, 0, 5 or 5, both are same. Okay, range function, what it does is returns a list of values. Okay, let's look at some different variants of range. Okay, I wrote 1 comma 10. Now it will start from 1, it will go to 10, but it will not include 10. Same here. If you don't give the first value, if you only just have one value, one parameter to your range function, you will have it will start from 0 up till your parameter. Okay, if you give 2 parameters, it will start from your first parameter end to your last parameter, but it will not include a last parameter. Hope it is clear. Now let's see the third option. I give 2. See, so these are spaced with 1. Okay, you can also give a spacer value. These are spaced with 2. I'll do is I'll write 1 comma 100 comma 5. 0 comma 100 comma 5. Okay, so we got numbers from 0 to 100. Each number is separated by 5, but it will not include 100. Is this clear? Okay, thanks. Let's see something more here. I wrote 100 to 0. Let me put 100 to 0. I won't add this. Okay, we got nothing. Why? Because if you start from 100, you can never go to 0, right? That's why you got empty list. Sorry. If you want reverse count, so what you need to do is you need to have -1 here. Then let me write minus. Let me put it 10. Okay. To start from the first operator, do -1 until it reaches 0, but it will not include 0. Okay. Now let's come to loops. First is for loop. Okay. Let's say we have a sequence of number as let's this. Okay. Now what we want is we want to print each and every element of this loop. How would we do this? We'll write for I in seq, I in your list, colon, hit enter, okay, print I. We got each element of your loop. How to iterate with for loop in Python? We use for I in list. Okay, and this should be anything which returns a list of values. Okay, if you want to do it using indexing, okay, we'll write for I in range 0, indexing starts from 0, comma, length of seq. Okay, oh, sorry, I forgot to mention one thing. This is a len function. If you want to find the length of any list, you can write len. Let me go to list. Yeah. To find the length of a list, you can write len inside bracket L. So you have 13. Why? Let's print what L is first. So we have L, these values, and there are 13 elements. So len of L print gave us 13. Okay, to find length of anything, just write len of len inside bracket the variable name. Okay. This len of seq will give us the length of this sequence. Okay. I'll write colon. I'll write print seq of I. Okay, and also print I. So at index 0, let's write index so it makes more clear. It is more clear. Okay. So at index 0 we have value 10. Okay. Index 1 we have value 9, 8, and so on and so forth. How it is working is this range 0 comma len of seq will give us something as let's print what this returns. Okay. It gave us range of 0 comma 10. If we list around it, we got 0 to 10, 0 to 9, sorry. So we have 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what this is these are indexes of your seq sequence list. Okay. So at index 0 you have value 10, at index 1 you have value 9. I hope it is clear. Okay. If you have any questions, please let me know. Otherwise, I'll move forward. Right. Let's look at while loops. Okay. I is 10 while I is less than 5. We can write print seq, sorry, and let me put it 0. Seq of I will do I plus equals to, sorry, I equals to I plus 1. Alright, simple. If you have any questions, please let me know, because the next topic is list comprehension, which I don't think most of you would be knowing. Comprehension. Any questions? Please put yes or no in the chat. Yes, Ritik. Do you have a question or you understood? Okay, thanks. Anyone else wants to? Anyone else has any question? Okay, I'll move forward. The next topic is list comprehension. Okay, let's take an example. We have a given a list of numbers. Okay, and what we need to do, we need to find square of each number in a new list. Alright. Let's say also give us, this is our list 1, 2, 3, 4, 5. Okay. So how to solve this? The easiest approach is this. We create an output list. What we'll do is we'll do for item in X, and what we'll do, we'll write out dot append item into 2. Okay, so append function adds a value at the end of the string. Okay, we'll do print of out. So we got 1, square of 1 is 1, square of 2 is 4, square of 3 is 9, so much and so on. So forth, we got the squares. Okay, but let's see the better approach. Okay. I'll write item into 2 for item in X. Okay, and I'll enclose everything in a list. Okay, any question on this? Is anyone having any question on this thing, what we wrote here? Okay. Let's see another example. Get all odd numbers from a list into a new list. Okay, let's see how do we do this. Let's say our X is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, what we want is we want all the odd numbers in our new list. Okay, with list comprehension, what we'll do is first let's see how we'll do using this. Okay, we'll write if item mod 2 is not equals to 0. Okay, and if this is true, then we'll add that item to our list and we'll append that. We got the output 1, 3, 5, 7, 9, 11. That is all the odd numbers. Okay, let's see how do we do this with comprehension. Okay. We'll write item for item in X if item mod 2 is not equals to 0. But if not dollar, it should be modulus. All right. So if we need even numbers, we can write equals to 0. We got even numbers. Odd numbers not equals to 0. Got odd numbers. Easy, right? Any question until here? Okay, I'll move forward to functions. Okay, to create a function in Python, we use a keyword called as def and the function name. Okay, then round brackets, colon, and our function body. Okay, let's create a function. This is just a syntax, so we'll create a function. We'll write def, say hello, and what this function does, just prints hello. Okay, how to call this function? So here we have declared a function or defined a function. How to call this function? We'll write say hello, the function name, and with round parenthesis. Okay, and it will execute the function whatever we have written inside after our colon and our function body. Okay. Can you please explain the functionality of this item into 2 for item in X? This input 98, you mean, Abdul? Okay. You understood this, right? Okay. For item in X, so what this means is for each item in X, okay, that is clear. Okay, and this is something which we want in our new list. Okay, let me, if I remove this, okay, what this means is put item into 2. Okay, put item into 2 for each item in X. Okay, put item power 2 or item into 2 for each item in X. Each item in X, what is each item in X? Every element in our X list. Okay, and we did this. So what this means, whatever we are getting from this, we are adding it to a new list. Now put item into 2 for each item in X, and where to put it? Inside a new list. That's why we have square brackets. Clear, Abdul? Okay, and if you want to think of it this, put item, okay, put item for each item in X if item is even. So this is the this is the condition for odd. Okay, what we are doing is put item for each item in X if item is odd. Okay, okay, we were at functions. We created a function of say hello. In that we added a print statement to print hello, and when we how to call this function, we just write the function name and the around brackets. So if a function, so function can also be parameterized. Okay, what do I mean by parameterized function? Create a function called say something. Okay, and whichever, this is called as parameter of function, and whatever you pass as a parameter of a function, what we'll do, we'll just print val. Okay, if I write val hello I am user. Okay, sorry, it was say something, not val. I'm right. Okay, so we call that say something function and passed this string, and what we are doing this function, whatever string we are getting, we are just printing it. So we got say something this. Okay, now if I write I'm not a user, so we'll print I'm not a user, meaning whatever we send something from here, that gets printed. Okay, what if I write this, I don't send anything from our function, we'll get an error. What that error is, that this function expects one parameter, but it received nothing. Okay, let's see how to fix this. Okay, what I'll do is, okay, say something, I'll redefine say something, and I'll write val equals to default. Okay, now if you call this, it will work. If you call this will also work. Now if you call this just say something, earlier it gave us the error. Now what will happen is it will work, and it gave us default. What this default is, this. Okay, so while declaring a function, if you in any of the parameters of the function, you write parameter equals to something, okay, that gets treated as the default value for that parameter. Okay, so if you don't, while calling this function, if you don't specify this val value, it will, so by default it will be this default value. Okay, any question on this? If you have any questions, please let me know, because our next topic is NumPy. Okay, if anyone has any questions, please ping in the chat. What I'll do is I'll create another Python file. I'll rename it as numpy1. Okay. All right. Before we start on numpy, okay, let's see what is numpy. So numpy is a linear algebra library for Python. Okay. So when it comes to data science or machine learning, you have to use. So machine learning is 95% mathematics, only 5% writing code. Okay. So you will have to use a lot of mathematical function, a lot of mathematical concepts. Okay. To make our lives easy, there's one library called as NumPy for linear algebraic operations. All right. That library is NumPy. All right. And one other thing, NumPy is the base of any machine learning or any data science library which you see in the internet. All the libraries use NumPy as their base. Okay, and NumPy is based on Python lists, not NumPy. NumPy has a data structure called Numpy Array. Okay, Numpy Array, or sometimes you will see it as NP Array. And this NP Array is based on Python list. All right. Okay. So if you have installed Anaconda, if you have installed Python using Anaconda, you don't need to install anything. NumPy would already be there. But if not, you have to install it using pip with command pip install NumPy. Okay. And I would suggest to use Anaconda distribution for Python works. Okay. Even if you are not using data science or machine learning, use Anaconda. Okay. Let's see how to use NumPy. Okay. Since NumPy is a third-party library, it is a third-party library. To use it, we have to import it in our code. Okay, meaning we have to make our code understand that whatever we are going to use from this NumPy library. Okay, and how would we do this in Python? We write import NumPy. Okay, just like that. Okay, but you would also see most of the times it is written as import NumPy as NP. Okay, and if we work on pandas, you will see pandas import pandas as PD. Okay, we have just as is like an alias of this. Okay, all right. How to import? We use import NumPy as NP. So either you can use import NumPy or you can use import NumPy as NP. Why we do it as NP, we'll see. Okay. Now our first topic is NumPy arrays. Okay. Excuse me. These are main way we will use NumPy. Okay. All right. And NumPy arrays are NP arrays are basically of two types. First is vector, second is matrices. If you know mathematics, then vectors are one-dimensional arrays, and matrices are 2D or ND arrays. ND means n-dimensional arrays. Okay. So this is the basic theoretical knowledge about NumPy. Let's come to writing code. Okay. First is how to create a NumPy, right? So we have a list. Let's call it my list equals to 1, 2, 3, 3, 4. Okay. We have to do what? If I print my list, we got list as normal Python list. We have to convert this Python list to a NumPy array. How do we do that? For that we have a function. We'll write np array or just array equals to np dot array. Inside bracket I'll pass on my list, the list variable. Okay. Now see, list will give you like this. If you have an NumPy array, you'll get this array. Okay. So this is what creating NumPy array from a list. Okay. Same way, if we have a 2D list, I'll do just copy and paste here. Okay. How to convert this? We'll write matrix equals to np dot array matrix. Sorry, my underscore matrix. If I print matrix, all right, we got a matrix array. Any questions till now? It was very easy. We just created list into array. Any questions? Okay. Now there's something called as shape. Okay, write array dot shape. We got 4. Okay, what is 5, 4 comma, not just 4? That is how NumPy is defined. Okay, so each NumPy array has one property called as shape. What the shape does is it tells you the shape of that array, shape of that NumPy array. So right now you see there are 4 elements and it's a 1D array. So we got 4 comma. Okay, if I write this, now this is treating this as a 3, 4 matrix, meaning 3 rows and each row has 4 columns. See, we have 3 rows and each row has 4 columns. So shape tells you the size, or let's say structure of NumPy array. All right. Okay. Now there are some predefined methods. NumPy. Okay, let's see what are those. Before that, I told you there are 2 ways to import NumPy, right? Okay. See, everywhere, wherever we are using NumPy functions, we are writing np dot. Okay. If you had imported using just import numpy, you would have to write numpy dot like this. Okay. To save this a numpy, every time writing numpy dot, we use a shorthand as np. We created an alias as np and we write array is equals to np dot array. Now there's there's one method called as arrange. np dot arrange. Let me write 0, 10. Okay. It is somewhat similar to a range which we had seen. Okay. See. So range gives you list. It is called as a range. It is meaning it will give you list with an array. You can think of it like that. Okay. A range will give you list with array. And whatever we had seen in range, we can do everything here as well. Okay. 0, 10, 5 meaning we'll start from 0. It will give next would be 5. Okay. So we got 5. Another would be 10, but we cannot include 10. So we got on 0, 5. Okay. If you write 0.5, see, started from 0, next is 0.5, then here we have 1, then we have 1.5, then we have 2, then 2.5, meaning 0 to 10 don't include 10, but each the difference in consecutive number should be of 0.5. If the list contains the different data values, will be output. What will be the output? Because array contains only same data values. You mean same data types, right? Yes. Okay. Let's come to the first line. The linear algebra library, and where we use algebra only on numbers. So your list should have numbers. Okay. All right. Let's look at how to add elements in array. Okay, we'll get to that. Wait, we'll get to that. Okay, so we are done with arrange. Next is something called as zeros and ones. Does anyone know what is identity matrix? No mathematics student here. Okay. We have np dot zeros. Okay, I wrote 3. What it will do is it will create a numpy array with value only zeros and of length 3. Right, Rajendra Prasad and right Sahil. Okay, so what does np dot zeros do? It will create an numpy array with values 0 as each element. Yeah, right, Ritik. Okay. If I write np dot zeros, let me write 3, 4. Wait, it should be like this. So if you want, okay, it should be like this. So it expects a tuple. It accepts 2 values in a bracket. So 3, 4 meaning 3 rows, 4 columns, and everywhere we have 0. Okay. Let me write it like this. Okay. Now this is a 3D array. Okay. Let me insert one row in between. Okay. 1D array, 2D array, 3D array. Okay. 1D array you can think of it like a like an array only. Okay. 2D array, you will think of it like rows and columns. Okay. 3D array, you will think of it like rows, columns, then pages. Okay. I mean, you can have any dimensional array with this, but the most you will use would be 3D. It's a 4D array would mean I have seen it used, but it's very rare to use 4D arrays. Okay, because with 3D arrays you can hardly visualize this. So with 4D arrays it becomes very much difficult again. Okay. Same way we have zeros, we have np dot ones. If I write 5 4, it will create array of 1 1 1 1 1 4 times. If I write 4 comma 4, let's write 4 comma 3. So 4 rows, 3 column, everywhere we have a 1. Okay. Again, you can create 3D here as well. 4 3 2, very easy. Okay. Now there's one more function called as Linspace. Okay. np dot linspace 0 10 3. Okay. It is same as arrange. Okay, it is same as arrange, but one difference, the last value here, okay, the last value here is not the difference which we had in arrange. Okay, here you can think of it like will give 3 evenly spaced numbers between 0 to 10, and here it will include 10. Okay, if we get linspace 0 10 50, what it will do is it will give you 50 different elements between 0 to 10, and each element is uniquely spaced. Meaning, what do I mean by uniquely spaced? That is, the difference between two numbers is always same. Okay, so if you subtract this with this, it would be same as if you subtract this with this. Okay. Now we have one more function called as I, np.I. So this I will give you identity matrix. If I write np.I, and if I write 4, okay, it gave us an identity matrix of length 4, and the diagonal elements are 1. Okay. Any questions till now? So we saw different methods. We saw how to create array with np.array. We saw arrange method. Okay. Then we saw zeros and ones. Then we looked at what this 2D and 3D means. Then we saw linspace, the difference between linspace and arranges. Arrange, the third element of the arrange is the difference between is the separator, or is the what should I say, the difference between two consecutive numbers. Okay. Next, what linspace does is the last parameter of linspace gives the how many numbers you want between the first parameter and second parameter. Okay. I hope it is clear up till now. And np.I gives you identity matrix. Okay. How to take input of matrix? You, Sahil, do you mean user input? Yes. Simply you can take inputs from inputs in a list, and you convert the list to a numpy array. Okay. To take input in Python, we use input function. Okay, let me show it. I write, and here you pass the message. Enter. Okay, I wrote 5. Now in that, whatever we entered, so whatever we entered was 5, so whatever we entered got stored to this variable. So now inp will have 5, and that 5 is of string. Okay, to make it to integer, we have to convert it to int using int like this. Now we have integer of 5. So what you can do is you can take multiple numbers from input and put it into them a list, then convert the list into an array. That's the only way. Okay. But the better way is if we use pandas, we'll read data from a CSV file. Okay, and then we'll use that CSV file to generate our arrays, and we'll use operations on those arrays. That's how we do. Okay. Any other question? I'll wait for 1 minute. If you have any questions, please let me know. Okay. Our next topic is random numbers. The first random number is RAND. Okay. How do we use this? We use it like np dot random dot rand of 2. Okay. How we will read some big data? We'll use pandas. So we use pandas. So pandas read data from a number of sources. So pandas can read data from a number of sources, one of them being an Excel file or a CSV file. Okay. So wherever we have to read some data from a file, every time we'll use pandas. Every time. Okay. Any other question? So now there's one mathematical concept called as distribution. Okay. There are number of distributions, number of types of distribution. Okay. There's something called as uniform distribution. We have standard or normal distribution. We have a polynomial distribution. Okay. So these are very mathematical concepts. Okay. Now this rand function. Okay. So what rand2 does is it generates 2 random numbers. Okay, in using a uniform distribution over 0 to 1. Okay, so what is uniform distribution? Uniform distribution means the probability of occurring any number between 0 to 1 is always the same. meaning we have same probability of occurring of having 0 as a random number if we generate a random number, and same as 0.1, 0.2, 0.3, 0.001. Everything, every number has the same probability. Okay, keep that in mind. Okay, what I meant by probability. Next will, so this is rand. If I put 2, 5, sorry, it does not take and take like this. Okay, so we have 2 rows, 5 columns. Everywhere we have a random number between 0 to 1. Now there's something called as rand n, meaning it uses normal distribution. I won't go too deep into normal distribution. Just think of it like it gives the numbers closer to the curvature, to the curve, more probable to occur. Okay. I won't go too deep into this because this requires some mathematical implementation also. I won't go too deep into that. I'll just use that function. Just you can see that there's one easy difference you can observe. Okay, see, a rand will give you numbers between 0 to 1. A random will give you numbers, can give you numbers from anywhere. Okay, can get -1, -2, anything. Okay, that is the difference you can observe. But how this comes, that lies between the mathematics and how this random is defined. Okay, see here, when we did rand, we did not have any negative numbers. With random, we have a lot of negative numbers. Some are less than 1, some are more than 1 also. Okay. Now, if you want just one random number, okay, for that we have rand int. Okay, I'll write 0, 100. So what it will do is it will give me a one random number between 0 to 100. Okay, we got 49. Next we'll do, we got 74, 73. Okay, if you pass one more parameter here, let's say I pass 10, what it will do is it will give me 10 random numbers between 0 to 10. Okay, next is reshape. Yeah, so we saw dot shape, right? Okay, let me generate another array. Dot arrange 0, 10, 1, 50. Okay. If I print array, so we got 0 to 14. If I write array dot shape, we got 15. Okay, hope it is clear. Okay. Let's create array 2 equals to np dot random dot random 0, 100, 10. 2, and let's see array 2 dot shape. So shape. Okay. Now this reshape. What this reshape does is it can reshape your array. So right now we have array of 15 columns, or let's say one column, 15 rows, 15 rows and one column. Okay, now what I'll do is I'll write array dot reshape 3, 5. What it did, it converted our array to 2D array of 3 rows and 5 columns. Okay, Same way I'll do with array 2, reshape 2 comma 5. So 2 rows 5 columns, or 5 comma 2 meaning 5 rows 2 columns. Okay. Now there's one thing you should also know here. If you write 5 comma 3, then you will get an error. Why? See this error. Cannot reshape array of size 10 into shape 5 comma 3. So if there's a matrix of 5 comma 3, that means that matrix will have 15 elements, right? But we cannot reshape a size of 10 into 15 elements. Okay? That's why we're getting this error. Any questions still here? Let's see how to get maximum and minimum from an array. Okay. We'll write array 2 dot max. We got 76. Let's print array 2 also. Array 2 dot max 76. 76 is the maximum. Minimum array 2 dot min 5, since 5 is the minimum. Okay. There's something called as array 2 dot arg max function. Arg max gives us 4. Okay. Meaning index of the maximum element. Same way we have arg min, index of the minimum element, that is 2. See, 0 1 2, we have 5 which was minimum, so and the index of 5 is 2. Okay. Any question on max min, arg max, arg max, arg max, arg min? Okay. There's something called as array 2 dot d type. Okay. So we have, so what this means is that this is the type of this array. This is the type of this numpy array. Type is integer of 32 bits. Okay. I hope it is clear, because next topic we have is operations on numpy. Okay, let's look at some basic operations. First of all, what we'll do, we'll import our numpy. Right, import numpy as np, and we'll create an array np dot arrange 0 comma 10 to array 1, array 2 equals to np dot random dot randend 0 comma 10 comma 10. Okay. Sorry, it is random. So array 1 has 0 to 9, array 2 has 8 6 0 0, some random numbers between 0 to 10. Okay. And the shape of both of them is same. Okay. Now let's look at something. I'll write array 1 plus array 2. See what it did. This added each element at each index. Okay. 9 plus 1 is 10, 8 plus 2 is 10, 7 plus 9 is 16, 6 plus 4 is 10, 5 plus 2 is 7. I hope this is clear. Same way, can minus 8 minus 5, normal subtraction at each index. Okay. Same way we'll have multiplication. Okay. Multiply 0 by 8, you will get 0. 1 by 6 will get 6. So we have 0 and 6. Okay. 2 and 0, 0. 3 and 0, 0. 4 and 8, 32. 0, 0, 32. Okay. So it is multiplying each element by each element. All right. Before that, let me do one thing. Array 3 equals to array 1 dot reshape 5 comma 2. Okay. Array 4 equals to array 2 dot. I'm just creating two 2D arrays. That's it. You can create however you want. I'm creating it like this. Array 3 has this. Array 4 has this. Okay. We can do same operations there. Array 1 plus array 2. Sorry, 3 and 4. Sorry, okay. Add each element at each index. Same works with multiplication. Okay. Now comes subtraction. Now comes, so this was subtraction, not multiplication. Now comes multiplication. Okay. Now, if you multiply two matrices by like this, okay, this is not a matrix multiplication which we know. Okay. If you multiply those two Numpy 2D arrays like this is not a matrix multiplication. Okay. This is just multiplying each element at each time. Okay. Each corresponding element we are multiplying with this. Okay. It's not a matrix multiplication. Okay. Now let's come back to our array 1 and array 2. Okay. Let's do array 1 divided by array 2. See, we got one warning. Okay. We got divide by 0 warning. Okay. What this is divide by 0? The divide by 0 is if you divide 5 by 0, okay, you'll get an error. This is Python division, Python true division. You'll get an error because you cannot divide anything by 0. Okay. But in NumPy, there's no such thing as divide by 0 error. You'll get a warning, and wherever you divide anything by 0, you'll get infinity. See, you divide 0 by 8 gave you 0, 1 by 6 gave you something, I don't care, 2 by 0 gave you infinity, 3 by 0 gave you infinity. Okay. Here it will just give you infinity, here it won't give you error in NumPy. Okay. You can also do inverse of, okay, no, 1 upon array. Okay, this is not as inverse of a matrix. Okay, this is not as inverse of matrix. What it is doing is it is thus doing 1 upon each corresponding index or each corresponding element. Okay, there's one more thing of array into 3. It will multiply, it will cube each element. If we do array into 2, it will square each element. If you do 4, it will do to the power 4 of each element. I hope it is clear. If you have any questions, please let me know. Otherwise, we'll move to our next and last topic, that is Matplotlib. We'll create some graphs using Matplotlib. If you have any questions, please let me know. Okay, I got one no. Anyone else? Please be responsive, guys. You're getting a free lecture. You're learning this. Please be responsive. Okay, Let me create another file. I'll call it matplotlib. We won't go too deep into matplotlib. We'll just discuss some basic features, how to create graphs. Okay. So first of all, there's one more name for matplotlib. Okay. Now matplotlib is called the grandfather of all the data visualization with Python. Okay. If you think about data visualization, so what is, first of all, what is data visualization? Data visualization is a concept. Okay, is a concept used to visualize the data, meaning you are storing a data in Excel files or CSV files. Okay, but that does not make any sense to you. Okay, once you create graphs or charts or different networks from it, you can get some knowledge from that. Okay, that is called as data visualization. That entire process was called as data visualization. Okay, and when you talk about data visualization using Python, okay, the first and the most basic thing you will use, that is matplotlib. Okay. Everything, like I said, in machine learning or any mathematical operations in Python, everything is based on NumPy. Same way, every data visualization concept or library is based on matplotlib. You talk about Seaborn, SNS, everything is based on matplotlib. Okay. But the downfall of matplotlib is it does not give you a lot of features, okay, that other libraries give you, but those other libraries use internally matplotlib. Okay, so it is recommended, or it is better to learn matplotlib, because the concepts which you learn matplotlib will be used in those advanced libraries. Okay. How to use matplotlib? Again, if you have did installed using Anaconda, you don't need to install it separately. Otherwise, you'll have to install it using pip install matplotlib. Okay. First thing we need to do is we need to import. Okay, how we'll import is will import matplotlib dot pyplot as plt. Okay, we'll be discussing pyplot of matplotlib. If you want to see how more advanced things are done using matplotlib, I would recommend you to join that workshop. Okay. Okay. So we have imported matplotlib's pyplot module, and we added a alias as plt. All right. Apart from this, if you're working on Jupyter, you also need to write this matplotlib inline. Why this? If you won't write this, Jupyter won't be able to render your charts. Okay, but when you write this but use matplotlib in, let's say, PyCharm or anything anywhere else, okay, there you don't need to use this. Okay, there matplotlib will create a separate window that there you will see the chart, but here we'll see the chart. If we write this, we'll see the chart inside our Jupyter notebook as well. Jupyter notebook only. Let's look at the most basic example. Okay. What we'll do is we'll generate some data using NumPy. We'll write import NumPy as np. X is equals to np dot Linspace 0, 5, let's say 10. Okay, I want 10 numbers between 0 to 5. see, we got 10 numbers between 0 to 5. Okay. And I want y. So a graph will have x direction and y direction. So this is our data for x direction. Now we need data for our y direction. Okay. What I'll do is I'll just square this. Okay. So it will give you y equals to x squared. So you know what this is? Y is equals to x squared. It's a function of parabola. Okay. Let's not go too deep into mathematics. We'll print y. So we have the square of each numbers. Okay. Now let's look at how to generate. So we generated our data. Let's look at how to create our graph. Okay. So what we did was we imported pyplot as PLT. Okay. So we'll write PLT dot plot. What we need to plot? So we need to plot x. At x direction we will plot x. I'll come to that question. So at x direction we have x, at y direction we have y, and we need to specify the color of the graph. I'll write R. Okay, we'll see what this is. And what we need to write? We need to write plt dot show. Okay, plt dot plot will take x, y, and color, the color of your graph, and then plt dot show. So we got our graph. Any questions on this? So if we to answer your question, if I remove this, okay. I think that was already loaded, that's why it is not working. But what happens is, if you don't write this matplotlib inline, you won't be able to use matplotlib in your Jupyter. Since we had already ran it before, so that's why it is taking that from its memory. So that's why it is still working. But if you don't write it, it will not render it in your graph, in your Jupyter. That is the use of matplotlib inline. %matplotlib inline. Any question on this graph which we generated? Okay, I'll create one more example. Let's use a range. Let's write -5 to 5 and difference of 1. Okay. Let's call it 6. So we have 5 in array. So we have numbers from -5 to +5. Okay. We just did yx squared. Okay, so now we have numbers like this. Now if I show the, see, so this is a parabola. Okay, like I said, so this y is equals to x square is the equation for parabola. So this is the parabolic curve we got using our plt dot show. Because at x direction we have values from -5 to +5. -5 is here, -4, -2, 0, 2, 4, and the values go from 25 to 0. So 0, this is the 0, okay, at here, and 25 to here. I hope it makes sense. Okay. What we can do is we can add labels here as well. We can write x label. Let's say write x direction plt dot y label. We write y direction. Okay. See, for text direction we just added labels here. Okay. There's one more thing you can do. You can add a title to your plot. Plt dot title and write parabol. Okay, we add a title here. So here you see we have written R is for red. Let's write G. We got a green curve. Okay, we can write blue as well. We'll get a blue curve. Okay. So we wrote R. There's one more thing we can do. I'll write double dash. Okay. Now let's see. So it will give you a dashed line. Okay. If I write asterisk star. So at each point, okay. So at each point, meaning at x, when x was -5, y was 25, we have a point, right? We have a star. X was -4, y was 16, we have a star, the point.